Hello and welcome to Chapter 7, Right Triangles and Trigonometry. In this chapter, we discuss the features of right triangles that allow us to do Pythagorean theorem, geometric mean, use special right triangles, and trigonometry. First, the Pythagorean theorem. The Pythagorean theorem states that you can add the squares of the lengths of the two legs labeled A and B in this diagram will equal the square of the length of the hypotenuse, labeled as C in this diagram. The Pythagorean theorem also has a converse, which allows us to determine whether a triangle is indeed a right triangle or not. The first equation of the converse of the Pythagorean theorem is C squared equals A squared plus B squared. It is identical to the equation of the Pythagorean theorem itself. Next, there is C squared is less than A squared plus B squared. And if this is the case, then the triangle we are dealing with is an acute triangle. The reason this is the case is that if C squared is indeed less than A squared plus B squared, then the angle of C is less than 90 degrees, which would make it an acute triangle. The final equation of the converse of the Pythagorean theorem is C squared is greater than A squared plus B squared, which would mean it is a obtuse triangle. And this is because the angle of C would have to be greater than 90 degrees. There are many special relationships within right triangles, the first of which is geometric mean. Geometric mean states that when the triangle ABC, shown, has an altitude of CD that forms two smaller triangles, which allows CBD to be similar to ACD and ABC. Because of this, certain proportions can be formed. The first of which is the length of BD over the length of CD is equal to the length of CD over the length of AD. The next proportion states that the length of AB over the length of CB is equal to the length of CB over the length of DB. Final proportion that we have is the length of AB over the length of AC is equal to the length of AC over the length of AD. Notice that in each of these proportions that one numerical value is repeated on both sides of the proportion. This is where the concept of geometric mean comes from. Next, there are two types of triangles known as special triangles that have specific angle ratios that allow each of their sides to have a specific ratio. The two most common are 45-45-90 triangles and 30-60-90 triangles. In a 45-45-90 triangles, the two legs have the same exact length and the hypotenuse is equal to the side length times root 2. 30-60-90 triangles, the leg that is opposite the 30-degree angle is known as x. Then, the leg opposite the 60-degree angle is known as x root 3. And with that in mind, the hypotenuse is always equal to 2 times x. As long as the angle measures are as the ones shown, the ratio between the side lengths will always remain the same. Finally, there is trigonometry. In trigonometry, there are three terms used to describe the sides and are used in the equation. The first one is the hypotenuse. Then there's the side adjacent to the given angle. And finally, there's the side opposite the given angle. These three values can be inputted into a number of different equations. These equations will allow you to find any given side length or angle measure as long as you know a single angle measure and side length. Thank you for watching the video. I hope you enjoyed and I hope it was to some use of you.